In this video, I'll provide a quick overview of the design of the PictureResponse example. I'll point to the nodes that handle different aspects of the design as I go along, but this video is mainly meant just to provide an overview of the methodological design. For more detailed information regarding the implementation of the various aspects of the design, please see the other videos in the series. Before we discuss the design of the PictureResponse example, we can do a test run to see what happens in the experiment. If we're not connected to a host PC and hence not connected to an eye tracker, then we should go to the iLink section of the Devices tab of the Structure panel and check Dummy Mode. This will disable the eye tracking functionality of the project and make it so that it doesn't attempt to connect to a host PC when we run it. Once we have Dummy Mode turned on, we can go to Experiment Test Run to test the project. It'll give us a little warning saying that we're running it in test run mode and we should not use test run for collecting actual data. This is really important because when you do test run after test run, it actually deletes old data files. So you should never use a test run for actual data collection. I'll say OK. Then the project will ask me for an eye tracking data file name, and this file name needs to be 8 characters or less and consist only of letters, numbers, and underscores. So I'll just use the default test.edf. It gives me a little warning saying we're in dummy mode and some eye tracking functionality won't be available. That's fine. Then the project will ask us which version or counterbalance of the project to use by asking us to choose a value for the list column of the data source. We'll discuss this in more detail in another video. I'll just use list 1. Okay, the first thing we'll see when the test run starts is an instruction screen that tells us how to perform the camera setup and do a calibration. I'll skip this by just pressing any key. And this will take us into the camera setup mode. When we're in dummy mode, we don't actually have to set up the camera or calibrate the system. Obviously, we're not connected to the host PC, but you have to know that you have to press escape to get out of the camera setup mode. So when you see the blank screen for camera setup mode, press escape. And in this example, it will take us to the instructions for the experiment. And it tells us to press Z for color images and / for black and white images, and to press any key to begin the block. So in dummy mode, the drift checks get skipped automatically. And the first thing we see is a color image, and I'll press Z for color. And it tells me I got that correct. And we'll see another drift check and then a black and white image, and I'll press / for black and white. And I get some more correct feedback. That's the end of the practice block. So we see these instructions again, and I'll press any key. And we'll see a color image. And this time I'll press / to answer incorrectly. And we get some incorrect feedback there. And now we see a color image, and I'll press Z to get it correct this time. And we'll get some correct feedback. Notice that the trials are in random order. We'll talk about that in another video. So here we have a black and white image. I'll press /. That's correct. And then we have another black and white image, and this time I'll press Z for color, which is incorrect. Okay, we'll see the final block instructions, and I'll press a key. And we have a color image. I'll press Z for correct. We have a black and white image. I'll press / for black and white. And we have a color image, and this time I'll press / to get it incorrect. And a black and white image, and I'll press / to get it correct. Okay, at this point, if we were connected to the host PC, the data file would transfer from the host PC over to the display PC. But since we're running in dummy mode, no EDF file is created and there's no file to transfer. So we get a little warning saying that no EDF file is created, and I'll just press OK. And now we can start talking about the design of the experiment. This example begins with some simple camera setup and calibration instructions. Following these instructions, the camera setup action puts the host PC and display PC into a special camera setup mode so that you can set up the eye tracker and calibrate it. Following this, the experiment proceeds with 3 blocks of trials. At the beginning of each block, The participant is given some instructions about what to do on each trial. Each block then proceeds with the trials for the block. The first block is a practice block consisting of 2 trials. The next 2 blocks are experimental blocks consisting of 4 trials each. The block ordering is structured so that the practice trials always come first, but the ordering of the experimental blocks is randomized. Within each block, the trial order is randomized. Each trial begins with some trial preparation, followed by a drift check procedure. Once this is complete, the eye tracker starts recording data and the critical trial events begin. First, an update attribute action resets the values of some behavioral data variables. Then, the participant is shown an image. The participant should press the Z key if the image is in color, or the / key if the image is in black and white. If the participant doesn't press a key in 10 seconds, then the trial times out. Following a response, the accuracy of the response is checked, and the values of the behavioral data variables are set accordingly. Some feedback is also provided to inform the participant whether the response was correct or incorrect. If no response was given in 10 seconds, then the participant is instructed to go faster. The feedback remains on the screen for 2 seconds, and then the trial ends with a blank screen. After the completion of all 10 trials, the experiment ends automatically and the data file is transferred from the host PC to the display PC.